Okay, so we're gonna start with our revision. So today we still are going on with electromagnetism, but today is the last part of it because we're gonna summarize all the concepts in this chapter, electromagnetism. I know that this is very heavy, difficult to understand, but I hope that by the end of this video you might be able to grasp a little bit of understanding for the whole concept introduced in this chapter. The first thing that we need is to up all the concept that we encounter. So basically, electromagnetism is just a combination of electricity and magnetism. So the phenomenon is very crucial because we will see later that it will be used as a generation for electricity and also transmission of electricity to domestic. So first that we need to learn is about the electromagnetism. So basically, it's a temporary method due to current flow in conductor. So due to current carrying conductor. So because of current flowing in the conductor in the wire, there exists magnetic field around it. We call it electromagnetic. In terms of old, older terms, we might call it induced magnet as well, induced magnetic field. But in our syllabus, it's not that important. Call it electromagnetic field instead. For magnetic field is also acceptable. So the rule that we introduced there to right hand grip rule for straight conductor. Right hand grip for solenoid. So both kind of use the rule differently. The straight conductor, our right hand grip rule, this the thumb shows the direction of the current flow, which is towards the negative terminal, whereas the rest of the four fingers shows the rotation of the magnetic field. The direction is either clockwise or counterclockwise. For right hand grip rule for solenoid, the fingers is actually shows the direction of the current flow in the solenoid as we see from the eye, the front of the eye, directly from the eye, not at the back. But the thumb actually shows the north pole, and that immediately after that we can know the south pole. And they must be so this to draw the field pattern, how you get left for higher, how you want to know the direction of the electromagnetic field, you just compass. But apart from that is the most important that we learn. And then the third, the strength of the magnet. Number one is current. The magnetic of current. Number two is strength. Number of turns. Coil for solenoid. Number three is presence of soft iron for solenoid as well. Number four is resistance, usually diving factor of wire. Okay, application. A lot. Metal cream and also relay. There's a lot application. We just focus on this four. Metal crane is the one that we use in garage where we want to lift up heavy metals such as old cars, or many more. We can use metal crane. So this is the heavy metal lift. Now we move on to the next one. Force. Current carrying conductor in magnetic field. This is also known as motor effect. Motor. So the rule that we introduce is actually Fleming left hand rule to determine the okay. So Fleming left hand rule. First, how you want to use this rule, the Fleming left hand rule. First, align the south pole first. This is represented by the magnetic field. The nails is showing towards the south pole. You must align the south pole first, and then the current either into the page, outside the page, whatever the direction of the current is, towards the negative terminal. And then by that we can know the direction of the force, either upwards or downwards, or to the out of page or inside the page. So that's the use of the Fleming left hand. Factors affecting the force. Because when we're using the Fleming left hand rule here, current is one of the things that we can change in order to produce the force. The other thing is magnetic strength of number 3, number of turns of important here. The most important one is the more important than the number of solenoid is actually the factor of resistance of wire. Okay, so what is the previous topic and this topic is this topic we have the electromagnet from before, the current carrying conductor, but that electromagnet is inside another magnetic field that is permanent magnet. So we have interaction between these two magnetic fields that is produced catapult force. Not catapult, yes, produce catapult force due to catapult field. So why is called motor effect? Due to force produced by catapult. Or we can say that this is resultant force as well. And they are both field due to combination interaction between the electromagnetic field and the magnetic field, permanent magnet. Okay, so now the application we use it in motor. Again, the factors of the strength, magnet, the shape of the magnet, the diameter, etc., etc. So DC motors use to change the direction of current flow every half rotation, which is 100 degrees. So that is the function of. So make sure that you know what is the process, how the DC motor works, the working principle of the DC motor, starting from this position, and then the 180 position, then the commutator will change the direction, causing it to continually to be in this position. And then process repeats. Okay, so next, electromagnetic induction. So this is another hard topic, but hard as compared from the motor effect. It is quite simple, but it's hard to absorb at first. So the electromagnetic production of induced EMF or current due to changes of magnetic relative motion of conductor in magnetic field. Okay, so basically what is the difference now? Before this we learned that if there is a changes in the charges inside the conductor, which means that the charges can move, that means there is electric current flow in the conductor, then there exists magnetic field. Now, what happens if the process is reversed? When there is changes in the magnetic field flux due to relative motion between conductor and the magnet itself, then there exists current, induced current, what we call, inside the conductor. So it's kind of a reverse process between the electromagnet that we learned before and the electromagnetic induction. There are the changes are for electromagnet is the current, the charges moving. But for the electromagnetic induction, the changes is the magnetic field flux. So the electromagnet will produce induced magnet, what we call electromagnetic field. The electromagnetic induction will produce induced EMF or induced current. Okay, effect. Over here. Now we have the test strength of magnet, number of turns of solenoid, resistance, which is diameter, factor of resistance diameter. So what are the tools that we introduce? We introduce Fleming right hand rule to determine the. So how we going to use that Fleming right hand rule? First, align the magnetic field towards the south, and then the force either upwards or downwards or forward or backwards. And then lastly, we can know the direction of the induced current either inside or out of the pitch. What are the other one? We also introduce right hand grip rule for solenoid. Again, everything once you see solenoid, you must think about right hand grip. So what are the law here? Two laws. Induction. The first one is Faraday's law. The second one is Lenz's law. Faraday's law discuss about magnitude of this current, whereas the Lenz's law discuss about the direction. Faraday law say, it says that induced current of induced current is directly proportional to the change of magnetic field. So basically the factors over here is all regarding the law. We change strength of magnet, then we change the magnetic field plug. We change the number of turn, we change the magnetic field plug as well. We change the diameter, we change the current, which is we change the magnitude of the resistance that the current can flow through it. Thus, we also change the rate of change of magnetic field flux. Law. Lenz's law state what? The direction of induced current is such that the changes cause it will be opposed. So what are the changes? The thing that we do to the solenoid. Either we bring the magnet closer, the magnet away, or the solenoid closer, or the solenoid away. That's the thing that we do. Then the mechanism is that thing that doesn't change, such as if we bring the magnet closer, then the solenoid gonna be at rest. Then the solenoid itself will oppose the motion that we do, the changes that we do. So, for example, if we pull towards the solenoid, so the solenoid will oppose the north pole such that the north pole will go away. So, how are we gonna do that? We must make the same pole. So, the solenoid at that direction at that point must be north pole. So by using the right hand grip rule, pointing your thumbs with the north pole, and then the current should be flowing downwards as shown by our nails. So that's one example. Another example is what happens if we bring the north pole away from the solenoid. So the solenoid itself gonna oppose that by attracting back the north pole towards itself. So it must have different poles. So it must be south pole. Okay, we can use our right hand grip rule, but this time our thumb pointing towards the left, and then our current should be pointing up by the nails of our fingers. So that's the first. So what are the application for electromagnetic induction? This is very important because it's revolutionized electricity, revolutionized our life. So we have DC generator and also AC generator. DC generator is computer is the function with DC motor to reduce the direction of current very hard rotation, whereas for AC generator we use brain to collect alternate current branches to reduce the direction of the current. So make sure that you know how to draw the curve for AC generator and for AC generator. The graph for the current time, current. Okay, and then the working principle as well for both generators. And then based on the application of electromagnetic induction, we can do more for AC current. We know about transformer. So transformer here, transformer is a device that can can step up or potential difference of alternating current. So this is very important later because we need to step up the potential difference before the electricity goes to the national grid network. We will explain later why we, and then we also need to step down to its requirement, the voltage requirement for each users, such as for every industries, for light industry, for offices, for houses, use different values of voltage. So then here, and we use the concept of electromagnetic induction. So we have the primary coil that connected to the AC supply. Then we have the soft iron core, and then the secondary core that connected to the load at the bar. Okay, so what are the things that we need to consider for transformer in order to make it more efficient? So the heat effect, number one, the heating effect due to resistance of wire. So how are we going to overcome? We can overcome it by increasing the diameter. And number two is eddy current. Okay. Heating effect due to eddy current. So how are we going to overcome that? We use laminated soft iron core. Number three, leakage of magnetic flux. How are we going to overcome that? We wind up the primary core above secondary core. Above primary core, we just doesn't matter here. It means that it must be closer to each other but not touching. As close as possible. Magnetization and demagnetization, or we call it, what we call it. So hysteresis. I'm not sure about the spelling, probably wrong, but you can check it later. But it's called hysteresis due to the lagging of the changing of magnetic field. So probably the current itself or doesn't produce the same effect as the magnetic field. So basically the current will be slightly faster or quicker than the magnetic field changes. The time taken for the magnetic field to change is slower. It's not in sync with the changes of electric current. So is there resistance due to magnetization and demagnetization of the soft iron core? That is the source of this problem. So how are you gonna overcome that? We use iron core. Because soft iron core has the properties that it can magnetize and demagnetize easily. So what is eddy current? Before we move on, eddy current is actually the current produced due to the induction, the process of induction inside the iron core as well. So what happens That's due to the lagging as well because of the hysteresis. There exists a small magnitude of current, induced current, due to the changes of the magnetic field flux of iron core. So that current, if we accumulate, it will produce such significant amount of heat as well. So we don't want the work done by the electric field and electric and the coil, the primary coil is towards that producing induced eddy current. We don't want that. We want most of the work done that we put in the transformer goes into the secondary coil, which our goal is to produce higher induced current, more induced current as much as possible. So again, eddy current is a part of the problem. So we need to use laminated soft iron core to prevent the heat from loss to the surrounding and keep inside the iron core, and probably will impede the movement of the eddy current as well. We will increase the resistance of the soft iron core, thus reduce the amount of eddy current inside the soft iron core, because higher resistance correlates with higher heat, higher temperature. Okay, then the factors. So transformer, the calculation is basically the ratio. Again, doesn't matter if you want to flip MP and S, VP, VS, it doesn't matter, but this is very popular. And also we have the power output over times 100% can also be written as secondary and primary. If ideal transformer, then the efficiency is 100%. So 100% here and 100% here can be cancelled out. So this power input here can be, so basically the input power must be equal to the output power. So it will be IT. So this is only for, if not stated in the question, you can freely use the formula. If stated that the transistor is not ideal by giving it the value C, then you can use this formula. But either way, you can also always use the formula for both cases, because we see that these ideal cases coming from this formula as well. Okay, so what's are the used in the generation and transmission of electricity? So this is our house. It has AC generator. How it works is you're going to rotate the turbine inside a magnetic field. So how are you going to rotate the turbine? By using steam or wind or water. So usually the steam is the most common one. How we generate steam? Either nuclear energy, either burning the fossil fuels such as petroleum or natural gas. So that's how turbine, the rotation causing rotation inside the magnetic field, causing the relative motion, causing the changes of magnetic field flux, thus produce induced current. So where you're going to go after that, we have to step up the voltage in order to reduce the current. So higher voltage, current decreases. So resistance constant, thus the power loss reduces. So the power loss here is I squared R. So the resistance is the same because we don't change the wire. We can change only the current. Reduce the current, overall will be reduced. Reduce the current by increasing the voltage for the potential difference. How are we going to do that? We use step up transformer. In order order to use the up transformer, it must be alternating current. So it must be AC generated AC. Thus, we can use the up transformer. And then the destination, we have to use step down transformer back in order to adjust according to the needs of the users. Such as for the heavy industry, it might be a little bit lower than the step up one. The light industry a little more lower. The office a little bit lower, and then the houses is the lowest one, usually around 200 current. So why voltage increase, current reduce is all due to the ideal cases over here, but it's not the transformer ideal, but we can assume it almost ideal. So the primary not gonna change, the power is not gonna change, so the power is also equal to the secondary coil. So the thing that we can change is the secondary coil here. You can also say that power delivered by the transformer is transferred to the national grid network. So if the power that leaving the transformer 500 watt, for example, then the national grid network, if we want to increase the voltage, then the current reduced to balance back to get, because we already add up more at the voltage, thus the current must be reduced to get to the 500 to maintain the values. So this is basically conservation of energy. So the power transmitted between the transformer and the national grid network are gonna conserve. And thus, if we change the voltage, the current also gonna affect it. If we increase the voltage, the current gonna be reduced. If we lower the voltage, the current gonna be increased. So I think that's all for today. A lot of things that we already covered for the whole week and last week as well. Hopefully you have a better understanding of this chapter. It's not that hard. The question is actually is quite straightforward for you to answer, especially for paper 3 and paper 2 for essays such as modification or making decision. But for the explanation itself is also quite doable, because it's only probably gonna ask about working principle of DC motor, working principle of AC generator, working principle of transformer, or how to produce induced current, how to know to determine the direction of by using Lenz's law, by using Fleming right hand rules. So again, all the concept is quite straightforward. You don't need to be demotivated when you encounter this chapter, because this chapter is quite fun but challenging due to the concept is a lot in here. But the calculation is just for the transformer only, and the formula is not that difficult as well, but you need to understand the concept of electricity beforehand, such as the Ohm's law, the power, and the series and parallel circuit as well, to know about the difference between the resistance, the factors of the resistance. Okay, so my advice is be careful. You don't need to stress yourself too much. If you cannot answer it, just leave it. If it's a choice, a question of choice. But for paper 3, I highly recommend to choose this experiment, because all the factors are repeated or exchange or interchange. If the year is the factor of diameter, maybe the next year gonna be factor of speed, of motion, of relative motion, or vectors of current, or vectors of strength of magnet, or vectors of number of solenoid, number of turn of solenoid. So it's, the experimental setup is almost the same, we just change the manipulated variable. So I guess that's all for today. Hopefully that we can answer this question very well, do more revision, do more exercises, and let me know if you have problems. So for the time being, you can check other video as well if you still have problem in some. So that's all.